Today we're going to look at another really popular concept in Algebra 2, and that's our rational exponents or our fraction exponents. Before we get started, we need to review our perfect squares and our perfect cubes. So I've got here, list all your perfect squares 1 through 225. So like 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and you made it, 225. Okay, there's your perfect squares. What about perfect cubes? We got 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 27. 4 times 4 times 4 is 64. 5 cubed is 125. 6 is 216. 7 is 343. 8 is 512. 9 is 729. And 10 times 10 times 10 is 1,000. Now, most of these really big ones we won't need, but this is now going to be a nice reference sheet for you on these notes. Now, a rational or fractional exponent. Great. Now they're fractions as exponents. Awesome. They can be rewritten as radicals. So I have an example here. If you have a to the m over n, if m over n is a fraction and it's your exponent, you can rewrite it as a radical. And notice that n becomes the index. N will represent the index. The index is the name we have for the cute little number that's in the check mark part of the radical. That's mathematically called your index. So whatever the denominator was of the fraction becomes the index, like a square root, cube root, fourth root, fifth root, things like that. And then a to the m will be the radicand, or what's inside. So if you have your square root, a in this case is the index, and this is the radicand. I have it written here with stars, and I'm going to highlight it. The denominator of the fraction that is our exponent, the denominator will be the index. If you can remember that, these are really easy to rewrite. So let's look at some examples. The first section, write each expression in radical form. Notice all of our problems have exponents, so we're changing it from the exponential form into radicals. So the first one, x to the 2/3. The 3 is the denominator, so I'm going to have a cube root of x squared. And you're done. Let me show you again on number 2, x to the 1/7. The 7 is the denominator, so I'm going to have a 7th root of x to the 1st, or you can just write the 7th root of x. Number 3, x to the 1/2. The 2 is the denominator, so it is a square root of x to the 1st. Now with square roots, if I don't put the index of the 2, if I leave it blank, everyone knows it's a square root, so you don't have to really write your index of 2 on square roots. And I also don't need to show an exponent of 1, so we can just rewrite number 3, final answer, as just square root of x. All right, number 4, and this is going to be the most important concept, is look at number 4, x, y to the 3/4. Who has the exponent? That exponent is only stuck to y. If it was going to be stuck to more things, they would have used parentheses to indicate it was attached to everything, but they did not. So I'm going to cross that out. The x is just the x. He's just chilling. And then y to the 3/4. So the 4 is my index, y to the 3rd. And that's your final answer. In the next section, we're just going to work backwards. It's writing them in exponential. You can see all of our problems are in radical form, so we're switching it from radical to exponents. Number 1 is a plain old square root of x. Now, the index there is an understood 2. There's also an understood 1. So when you go to write this, it's x to the 1/2. Remember, the index from the radical becomes my denominator. Try it again on number 2, plain old cube root of x. Again, you have an understood 1, so it's going to be x raised to the 1/3. Number 3, 5 is the index. That's going to be my denominator. So x to the 4/5. Number 4, a fourth root of x cubed. The 4 is my index, so it's my denominator, x to the 3/4. Just working back and forth, back and forth. And so I think these are mixed on Delta Math. So keep your eyes peeled. You're just moving from radical to exponent or backwards. Number 1 in the next section is just simplify. So we're pulling all of our exponent rules together. Now I've got 1 over 3x to the 1/2. Similar conversation we had a moment ago. Who has that exponent? Just x. It's not stuck to the 3 as well, or they would have used parentheses to show us that it was attached to both. So I've got 1 in the numerator, 3 in the denominator, and I'm going to change the fraction exponent to a square root of x to the first, or I can leave it as an understood square root without the index and an x without the 1. Number 2, look, you have parentheses. Everybody gets a negative 1/4 exponent. But look there, that's a negative exponent. You remember what happened to negative exponents? They're going to move down into the denominator. So we're going to have 1 over 3x raised to the positive 1/4. And then let's change it to a radical form. So everything is in this fourth root, 3x to the first if you wanted to, but we don't need to. Number 3, 1 over parentheses. Everything in the denominator, 2x squared plus 7, is raised to the 1/2. So the 1 is staying. Everything is in a square root, 2x squared plus 7, or you don't have to put the 2 on your square root. Number 4, we've got a negative fraction exponent in the denominator, and it is only stuck to x because I didn't use parentheses. If you have a negative in the denominator, a negative exponent in the denominator, it moves up. So now I have x to the 4/3 in the numerator over 2. What happened to my 1? I didn't need it. It was in the top, and 1 times the x to the 4/3 is still going to be x to the 4/3, so you don't have to write that. Let's change the fraction exponent to a radical. The denominator is 3, so that's a cube root of x to the 4th over 2. At the top of your second page, I put a review of all of your exponent rules. We've already used a few of those already. If you have a power raised to a power, you multiply. If you have several things in the parentheses, they each get the exponent. If you have like bases and they are multiplying, you add the exponents. This is the one I want to remind you of. If you have the negative exponent, it moves down into the denominator and becomes positive. Or if you have a negative exponent in the denominator, it moves up. And we've already seen that a little bit on our previous examples. If you are dividing like bases, subtract their exponents. And if they are in parentheses, each thing gets your exponent. But biggest thing I wanted to review is that negative 1. So we are going to simplify our expressions. We've done a little bit of this in the past, but we're pulling in those rules now that we have fraction exponents. You can see number 1, the quantity of 27x to the 12th y cubed, all raised to the 1/3. So there are 3 things in these parentheses. So I'm going to give each of them the 1/3 exponent. 27 to the 1/3. X to the 12 raised to the 1/3. That's power to power. That's that first rule up here that I need to multiply them together. So I'm going to do some scratch work to the side. 12 times 1/3 equals 4. You can cross simplify there, and we get 4. X to the 4th y to the, it's a y to the third, and then we're also raising it to 1/3. So what is 3 times 1/3? 1. So y to the first. All right, keep going. We have a cube root of 27 to the first, x to the fourth, and a y to the first. Now, at the beginning of the notes, we reviewed our perfect cubes. So if you take a cube root of 27, what number was multiplied together 3 times to make 27? 3. The cube root of 27 is 3, and we have x to the fourth, y. Final answer. Number 2 also has 3 things in the parentheses, so I'm going to give each of those that exponent of 5 to the third, 8 to the 5/3, x to the, it was -9, and we are raising it also to the 5/3. So power to power multiply. You can simplify to help you get a -15. And then y to the, it was -18, and we're going to multiply it with 5/3. Gives me -30. All right, rewrite. We're going to have a cube root of 8 to the fifth. And then I have negative exponents here that are going to move down into the denominator. An x to the 15th in the denominator and a y to the 30th in the denominator. Now, I don't know the cube root of 8 to the 5th, so let's grab the calculator and I'll show you how to plug it in. On your calculator, you're going to add a calculator page. If you hit Control and you go down to the caret button right here, you can see that control function is an nth root of x. And on my calculator, it opens up that radical with open boxes for both. So in my little box, I'm going to put my 3 for my index, and in the big box, I'm going to put 8 raised to the 5th and enter 32. So I'm not crunching numbers trying to figure all this out. Utilize the calculator. This is 32 over x to the 15th, y to the 30th. Final answer. Number 3 also has 3 things in the parentheses, so 9 to the 3 halves. X to the, it was -14, and we're multiplying that with 3 over 2. I can cross simplify and see that I get a -21. X to the -21. Y to the, it's -16, but power to power multiplied with 3 over 2, I can simplify to help me get -24. Y to the -24th. Now we do have negative exponents that are going to move down into the denominator. Both of those, the x and the y, are going to be in the denominator. And I'm going to change my fraction exponent with the 9 to a square root of 9 cubed. And we're moving the x and the y down to the denominator, and they're becoming positive. Now, square root of 9 to the third. Let's use the calculator. Now you can still do control in the caret and plug in your own 2 for your squared, and then 9 to the third. Or you can do control and the x squared button gives you a square root and just do 9 to the third there. Either way, we get 27 over x to the 21st, y to the 24th. Number 4 has 3 things. 32 to the -2/5, x 10 times -2/5. I'm going to simplify and get -4, so x to the -4th. Y to the, it was -20, but power to power multiply that with -2/5. Simplify to help me multiply and get 8. Y to the 8th. I'm going to move my negative exponents to the denominator. The y to the 8th staying in the numerator. The 32 is a 5th root. 32 squared, x to the 4th. Now let's use the calculator and figure out what that 5th root is. So control and the caret button gives me the 2 boxes with my radical. It's a 5th root of 32 squared, 4. Y to the 8th over 4, x to the 4th. Final answer. No more fraction exponents, no negative exponents. Everything is changed into radicals and simplified. So again, a major concept, we're going to see lots of simplification problems involving fraction exponents, simplifying exponents, radicals, and things like that, probably on the non-calculator portion of our benchmarks or our end of course. And so get familiar with that. Um, Again, they're going to show up everywhere, especially just a basic simplifying, honestly. Like we saw like in our first couple sets of examples, just changing it, knowing that your denominator is the index. Huge deal. So a lot of students will miss those types of questions and they just have their fractions flipped or they have their radicals written incorrectly. So really simple concept that we can lock in, and these can become really easy questions for us on our benchmarks and tests. Practice those. I'll see you in class.